Okay, we are moving on to 6.4 now. This will be the last section before we take our quiz on Friday over chapter 6.1 to 6.4. 6.4 is proving triangles similar by angle. Okay. If you remember AA, again, very similar to those things that we learned earlier, the ASA, the AAS, SAS, SSS, all that stuff. Except this time we're just talking about AA, and we're not proving triangles to be congruent. Instead, we're proving triangles to be similar by AA. If you remember, we didn't have a way to prove triangles to be congruent using AAA, or angle, because what you should have already figured out from these sections is that you can have two triangles with all congruent angles, but they're not necessarily the same size. Those could be proportional. Okay, we've talked about that already. So with that being said, if two angles are congruent, if two angles of a triangle are congruent to two angles of a second triangle, then the triangles are similar. And partly because something that we have already learned. If you remember that property, that one property of similar triangles or similar figures is that the angles are congruent. So if two of the angles in a triangle are congruent, the remaining angles have to be congruent as well. If you remember, that's from the third angle theorem. That basically said if you have angle 1 and 2 congruent to angles 3 and 4 of another, or angle 1 and 2 congruent to angles 4 and 5 of another triangle, then angles 3 and 6 also must be congruent. Okay? If you can't remember that, go back and look up third angle theorem and just kind of go over third angle theorem again. But if two angles of a triangle are congruent, then that third angle must also be congruent. Okay? All right, so what we're going to do is we're going to check to see and prove that triangles are congruent, not congruent, are similar by getting their angles to be congruent. All right, so let's take a look. So let's say that we have these two triangles, a triangle ABC here, and we have triangle DEF, and we are given this information right down here that says that angle A and angle D are right angles. And we're also given that angle ABC, that's this angle right here, is 36.5, and angle DEF, so DEF, that's this angle here, is 53.5. And we said that angles A and D are right angles. Okay, now 53.5 and 36.5 are not congruent. So at this particular point, we cannot make a similarity statement that ABC is similar to DEF. But what we can do to check that is we could say, okay, let's see what the other angle is. What is the measure of angle C? Okay, what is this measure? Well, we know that we have 90 plus 36.5, and that equals, plus X, or angle C, should equal 180, right? Okay, so what that does is when you add 90 and 36.5, you get your 126.5. Plus angle C equals 180. Subtract 126.5 from both sides. You find out the angle C is actually equal to 53.5. So this angle right here is equal to 53.5. So if that's equal to 53.5 and angle E is equal to 53.5, you now know that these two angles are congruent. If these two angles are congruent, and obviously the right angles, angle A and D, are congruent because that's the definition of right angles, they're both equal to 90 degrees, then angle B and angle F must be congruent, and now you can make that similarity statement and say that triangle ABC is similar to triangle DEF. Okay? And again, this is your similarity statement right here. Triangle ABC is congruent to triangle DEF. You can go on to extend this particular lesson if you were so inclined to do so, and you can say, okay, let's say that AC, now knowing that these are similar triangles, AC is equal to 5 centimeters, and DF is equal to 10 centimeters. What is the ratio of triangle ABC to triangle DEF? Well, using our scale factor, we're going to say it's 5 to 10, right? I know that AC, here's A, here's C, goes with D and F because of the order in which these are labeled, right? So my ratio is 5 to 10. If I reduce that, I could say 1 to 2. And I say 1 to 2 because I'm talking about going from the small one to the big one. If I went the other direction, it would be 2 to 1 or 10 to 5 or whatever, but we always want to reduce that if possible. So then if I said DE was 14, what side would go with DE? Yeah, DE goes with AB. So AB then would be 7 centimeters. So you can find out a lot once you figure out that the triangles are similar. As always, if you have any questions, please feel free to write those down. Email me at misggeometry@gmail.com or come to tutoring in the morning or after school. All right, let's look at another example. These questions right here often get students confused only because you're looking at two triangles, but they're embedded within each other. So the question's asking you, is triangle GIF, okay, that triangle, is it similar to triangle GKJ, the big triangle? So it's a little triangle inside the big triangle, similar to the big triangle. One easy way to work this particular problem out would be to draw two separate triangles. Here's one, and then we could draw a bigger triangle. And just relabel it like normal. So here's G, I, H. Here's G, K, J. Now, in order to determine if the triangles are similar, we need to go ahead and find that two angles are congruent. Well, what angle can you immediately figure out is congruent in both triangles? Yeah, you should say that angle G is congruent to angle G. That's a reflexive property, right? So you know that angle G is congruent to angle G. So that's one. If I can just figure out that J is congruent to, if I can figure out that J is congruent to I or H, or I is congruent to K or J, then I can figure out that these triangles are similar. Now, the problem is it doesn't give us any other angle measures, but what does it give us in order to help us determine if these triangles are going to be similar or not? Yeah, if you look right here, you see these two markings right there, and those markings indicate that those lines right there are parallel. So knowing what we know about parallel line, we have to go kind of way back to figure out that. What we know about parallel lines, we can figure out what? How about this? How about angle H, GHI, okay, is congruent to angle J? Why would those two angles be congruent? Yeah, angle GHI and angle HJK or GJK, let's use that one because that's a little easier to understand for our other triangle. They're congruent because they are corresponding angles. Okay, so here's our transversal, here's our parallel lines. Here's a transversal. Those are in the same spot, right? Those are corresponding angles. Corresponding angles we know are congruent. So now you can say that this angle right here is congruent to this angle right here, which third angle theorem will tell us that that means this angle here is congruent to this angle here. And so then, is triangle GIH similar to triangle GKJ? The answer is a resounding yes, with enthusiasm. Woo-hoo. All right, and our final example. You often see these ones on standardized tests, which you guys don't have this year. Lucky you. Okay, but we want to figure out how tall the tree is. What we can do to make this easier, because right now what you're seeing is you see the sun over here. Maybe. Not that. Here's the sun over here. And it's casting a shadow, right? So the tree's shadow is going to go all the way past the man's shadow, right? What we can do is we can create triangles. Based on what we just did, we can take this and say, okay, here we go right here, and we could take this right here and essentially create two right triangles. Okay, one triangle within another. So right here we know that this angle right here is going to be right, and this angle right here is going to be right. Okay, because before we can do the math, because I know like in 7th and 8th grade we want to jump right in, do proportions, call it a day, but we're at a higher level of math now, so we've got to prove that these are similar before we jump into that proportion. So I'm proving that these are similar, so now I have a right angle, and then of course here's your angle right here that is within both triangles. It's part of the big triangle and it's part of the little triangle, so those are congruent through reflexive, so the triangles are similar because of that. So now because they're similar, you can set up a proportion. Okay, and if we use corresponding parts to set up a proportion, you can say that 6 feet is to what? How high the tree is. Okay, so we'll call this X. And 6 feet casts a shadow of 54. Over, now this is only 177 from here to here. So what does it need to be over? Does it need to be over 177? Or does it need to be over 177 plus 54? Yeah, 177 plus 54, which is 231. Okay, and now you can set up your cross multiplication and division, or set up your algebra problem where you have 6 times 231 is equal to 54x. And you can work this problem out and get that x is equal to 25.7 feet. So the tree is 25.7 feet. Another way you can approach this problem, and just to kind of answer your question before you ask it, because this is the question I would ask, is can I put the height of the guy standing there over the height of the tree? So over the height of the shadow, the length of the shadow. So can I put 6 over 54 and set it equal to the height of the tree over the length of the shadow, which is that 231? Can I do that as well? Will that still work out? Well, if you look closely, you're still multiplying 6 times 231, and it still equals 54 times x. So the problems from here to here are the same. So in the first part over here, in this first section, I did the corresponding parts, meaning the height of the man over the height of the tree, and the shadow over the shadow. In the second part here, solved the same problem, got the same answer, but instead this time I did height of the man and his shadow, set it equal to height of the tree and his shadow. So you can do same figure, same object, okay, equals same object, or you can do corresponding parts equal corresponding parts. Either way will work. And again, pretty much it. So far, so good. I don't think we've come into anything that's too terribly difficult, anything that's too terribly new. So hopefully this will be just simply more review, and this should be a relatively easy quiz on Friday, relatively easy test when we take that test come January 22nd. All right, if you have any questions, again, please let me know. You guys have a great night.